keynote talk today.
Yeah. Thank you, TLM, for this brief introduction. Welcome note. Now we are moving to our first session of the invited talk. The session talk will be, the invited talk will be given by Professor Heli Valtna, and she'll be giving on the mapping the path from idea to economically scalable application in 3D imaging and sensing. Now I welcome Andre to give introduction about our speaker.
Hello, can you hear me?
Yeah.
Okay, that's great. So, Heli Valtna, Ph.D., is a co-founder and the CEO of deep tech startup LightCode Photonics. Heli Valtna holds a Ph.D. in physics, specializing on wave optics from the University of Tartu, Estonia, and completed postdoctoral studies at the Max Planck Institute for the Science of Light, Germany. In 2017, she was awarded with the Young Scientist Award by the Cultural Foundation of the President of Estonia, and she is a member of the Estonian Young Academy of Sciences. LightCode changes the way a robot looks at you by delivering the world's first software-defined 3D camera for the service robots to automate mobility-related tasks on ground, at sea, in air, and in space. LightCode uses an innovative approach for acquiring 3D images based on decades of research in optics and light detection. They package LiDAR performance into an economical and compact 3D camera. This is a breakthrough technology for mobility.
So, hello, thank you for the kind words. And let's start with the presentation. So, to see or not to see is still the question for many robots that are designed to help us out with tedious, repetitive, and dangerous tasks. And that's why at LightCode Photonics, we are building innovative 3D cameras to give eyes for the robots. And today, I will first introduce the LightCode briefly, and then take two topics in addition. One of them is why we are doing it, or like why to do the innovation. So what is the defining force behind it for the success? And second topic is how to make it happen. So what are the key aspects we should be paying attention to? Let's get started. So it was 4 years ago. I had been in academia for 20 years, shaping lights, making light bullets faster than light in a research team together with co-founders and Professor Peter Saari. One of my colleagues was sending light bullets around the corner. And I was at that point head of autonomy development for off-road autonomy. I was just signing or negotiating the largest academic and private sector agreement between my company at that time and 7 research teams in academia. And my team was combining 6 different modalities of sensors in order to give enough perception to the robot to navigate autonomously at autonomy level, something around 2.5. So the levels are that first you take feet off, then you take hands off, so you have some automatic control, then you take eyes off, and then you take mind off, and then you don't have the wheel in the vehicle anymore. So that was the standard. And perhaps the most important outcome of those experiences was that it's a common misconception that the robots can see, and there is an autonomy in some of the shelves just to take and plug it on. I have to break it for you. The robots cannot see very well. Often they use really limited sensors. For example, just a 2D line scanner. You can think of a laser pointer, and then you can think of scanning it around. Or variants. 2D cameras are not enough for their navigational input because they don't perceive the distances. We have the brain and we make an estimate, and according how fast we move, then it's like sufficient. But for robots, they are not equipped with such capacity, but instead they have to work with really optimized compute, and that will not process the visual information as we do. So it's a challenging task, and that's why the robots need to perceive the world, but still keep the data flow optimized and so forth. So that's a really massive challenge, and there's more than 100 companies actually developing 3D cameras for the robots, and the majority of them are in really early stage. There are only a few commercially accessible solutions. But what's the gain of it? So the gain is that such vehicles that drive on sideways or in warehouses or some other open spaces, airports, for example, and industry environment, they could now replace the human operators that are still really, really hard to find. So, that's it's a fully automated solution in this in those environments would enable to deliver the cargo much more efficiently and at much lower costs. And in addition to solving this labor shortage issue, it also helps making logistics green in terms of energy, to switch from fossil fuels to electricity-powered vehicles that can be totally green in terms of. So there's a huge gain from that. And what we do at LightCode is we are combining this unique imaging concept. It's here one pixel imaging, single pixel imaging variant of we're complementing in a way ghost imaging that originally stemmed from quantum optics. And if I give one characteristic of it is that it's counterintuitive. But what it actually enables is to enhance the pixel resolution. So if we have enough time, we could take one pixel and measure 1,000 pixel scene or even million, but we would just need a lot of time for that. So there's obviously trade-offs, and we need to optimize. But those low pixel count sensors, they doesn't cost much, but they have really features that are not accessible in high-resolution sensors. For example, well, we started, we moved into our own premises 2 years ago. We're in the science park in Tartu, and 2 years ago, our technology did fit into a huge luggage suitcase. It had scientific rated components so that some of them didn't have a price and others cost maybe 30,000, so it's not commercially viable solution. But today, the team has developed, has reached this demonstrator prototype, which has, it looks a bit larger than it is. It's actually, well, some people say it's a pocket size, and it's less than 1 liter in volume. And this is like not the final destination, but it's a demonstrator. The next version will be even smaller. So, and what we do here, we take 12 pixel sensor and we measure 1536 pixel image with it. And in order to achieve it, we have unique algorithms and we have specialized electronics inside. And how this a single pixel imaging actually works, we can see on this slide. So here's a scene, not very contrast, but it has source object. It's 1 meter from the wall and 2 meters from the camera. And with 12 pixels, color showing the distance or depth, it would say that there is something at those pixels. But now if we apply this light-guided zoom or dynamic pixels, as we now call it, we enhance the resolution 128 times. and the object becomes clearly visible. It also has dependence on the reflectivity through the intensity here of the measurement. So this is in essence what we do. And now this is LightCode's team behind it. We are 18 people in 3 offices on 2 continents. And we have a lot of advisors, international advisors, and believers all over the world. So that's a great thing. And well, that was the first part of the presentation. So what is LightCode? So now the second question, like why the market matters. And here I would give an example that let's think about the great innovators from the past. I think Henry Ford is a really well-known name, showing that if you innovate at the right time for the right market, you will have huge economical return. So he's among it's position 12 in America's 50 most wealthiest persons at their time. And there's another extreme, which is let's imagine Nikola Tesla. I mean, he was really excellent spokesperson, but he did something that was not needed at his time. So he was so much ahead of time. I mean, now we use electricity everywhere, but when Tesla did his innovations, it did not yet go to masses so fast. So from those 2 extremes, I would say that the market defines either you end up like Henry Ford or Tesla. And well, you can also train and shape the market, but it's a question like if quantum computers would actually make someone rich during their lifetime or maybe a bit later. So well, that's a guideline to decide if you continue in academia or do you start a business on your own. So if you have a hot market you can service, it has turned from a vertical operation that you have to provide everything yourself into horizontal that has socket for your technology. So this is another like highlight here. And I have really good news for everybody in optics, photonics, holography, because 3D sensing and imaging market, which is like the main target, is, and here it's one of the many market research overview slide. But what is 2 numbers are important here is the market is growing 24% annually. Annual compound growth rate is a really good growth. It's going really fast, and the market size by year 29 is with $115 billion. It's huge. So that's a really good news. So now something that might be confusing. On the next slide, here's a different market research from a comparable time. And it says the market size is $100 billion so smaller around the same time. So that's to be expected. But here we see that the growth rate is comparable, and well, the order of magnitude is not so different if we compare it to the years and so forth. And the standing point probably is quite well aligned. So. And why I did bring this slide here is that it has the market segmentation shown here at really still high level, but like medical imaging we find here, it's not growing really fast, so it's a rather difficult market. But here are others like automation, industry automation, mobile devices grow rapidly. Like we see that in 5-6 years, it is like expanding a great deal. And the predictions also say that also the medical market will grow faster and defense will slow down. So this is the guideline. this is what to be expected. If your market is shrinking, then probably this is not a good idea to enter that market, unless you can really, I mean, you're equipped with a lot of resources and you have long time to wait and change that. So to summarize, the market is something that will define, like, will you end up like Nikola Tesla or Henry Ford? But if like just making your name known, then both solutions will do really well. Just have to be a good innovator. And now let's come to the third, and I think it's the most crucial characteristics is the innovation, and especially innovation process and understanding the process. And here I have selected 3 quotes. This first quote is from one of my colleagues. It was year 2013. It was September. I was in Max Planck Institute from my postdoc, and I was presenting after being there for 10 days. I was presenting my research plan. I said already, I've been here for a week, and now it's like last time to get started. And I said that I will be measuring the duration of 2 femtosecond pulses. And one of my colleagues, number 2 in the team, he said that this cannot possibly be done. Well, it was, because I also run a lot of numbers, a lot of analysis, and it did work. It was maybe a bit longer step than I anticipated. So in order to make it like rigorous experiment to nature level, maybe it would have taken 5 years. But in this 1 year, 1.5 years, 2 years I spent there, I was able to demonstrate, and I was like really, it was a like massive journey, and I enjoyed it a lot. So this is like one of the benchmarks that at LightCode, the team photo I showed, here most of the people say, if somebody says this cannot be done, then okay, now we got just started. So this is the characteristics how to choose a team. And here's another one. This was my last academic grant application I wrote, and that was one of the anonymous reviewers who said that from the innovation I just presented, they don't anticipate my major financial input from industry anytime soon. And well, yeah, I mean, probably they, from their experience and standpoint and all the conditions, they had all the right to say it. But there's another famous speech by American President Theodore Roosevelt. It's a man in the arena, and it says that it's not the critic who counts. So here we are in just 3 meters from me. I have a stand. So LightCode is 2.5 years old. And the stand is full of different innovation awards. So we have not yet made it into product. We have not made it into fully viable business, but we have definitely made it into different radars of Forbes 100, several Forbes 100 companies we have been negotiating and are negotiating and discussing with. We just completed Intel Ignite Accelerator with award for most progress. So whatever we do, keep in mind what Theodore Roosevelt said. It's not the critic, but the man in the arena who counts. So, and now let's dive into the process, because this is the make it or break it. Like market is condition. You should choose the market, but the process is something that either like succeeds or makes you fail. So and here's like oversimplified approach what the innovation is. Like someone has idea, then there's innovation, and there's a product comes out. And understanding what the innovation is, what's behind this mess here, so this is the crucial thing. And this simplified model says that owners have the idea, and then engineers do the technical solution. There's the product is ready, then the salespeople come, business happens, and the customer has product, and the owners have the funds. As I said, that's oversimplified, and we need to dive into to this middle ground here. So how the idea becomes a product. Because otherwise, if we don't, then this common misconception might happen that different people understand the situation completely different, and the solution will be far, far from what is expected, and well, there's no business in this case. So two critical things is customer needs and expectations. And now another super simplified model is a family dinner. Imagine a family of 5 and different members there, and the dinner is served beetroot oat porridge. So there might be people highlighted in green that might like it, and the yellow might also be willing to eat it. But those reddish colors mean that this is definitely a no-go, despite it meets all the needs of the audience, but not the expectations. So the most important thing in order to make the innovation commercially viable is to manage the expectations. And also acknowledge that even for this short-term project like a family dinner, the expectations might change. So if you're talking about innovation process that goes through all the known technology readiness level steps, this is several years, if not a longer process. It can be for space technology, it can be tens of years. Or massive research infrastructure. So these expectations need to be managed properly throughout all the development. So this is crucial thing in order to succeed. And so really good benchmark for the innovation, what it is, are those technology readiness levels, originating from NASA in 70s, also now adopted in European Union, and it's pretty much standard for any innovation. So, and what they actually are, how we could make sense of those, is they're often grouped into 3 groups. So first 3 from basic principles observed to experimental proof of concept are considered basic research. So this is what I was actually doing in academia and having a lot of fun. So now the second group is from 4 to 6, is from technology validation. So validation is more than first demonstration to demonstration in relevant environment. It's still a demonstration, and technology, not a system. So this is often considered applied research. And now from 7 to 9 is system prototype demonstration to actual system proven in operational environment. This is product development. So, and today with LightCode, we are here at 7. So we have system prototype. So this is what I'm holding in my hands. So this is demonstrator, system demonstrator. We call it ourselves 0.9. And it's a core architecture. What we are going to add here are additional features that arise from this really unique approach, how we are looking at the world by counting every single photon detected in this camera. And so now for every innovation, resources are needed. And here it's important, acknowledge what level of resources, because it's changing. We cannot average it out. It's exponentially growing towards the more maturity. And what is important to perhaps highlight that if levels from 2 to 8 I'm deliberately leaving out first because here we are combining like all the knowledge from the starting of the times in the relevant domains. So this is standing on the shoulders of giants. So that's that part. And so from 2nd to 8th are mostly internal, and the 9th is like validation in operational environment. So this is also shared with early customers, piloting partners, test validators, so forth. So this is again somewhat shared. But from 2nd to 8th, the resource need is growing, and this is to be acknowledged before anybody starts that journey. But here's a hidden cost, because if we discover something, it's just like this mythical creature Hydra, that if you cut one head, several others will appear. So if you solve one question, then you definitely get several new perspectives and new ideas how to explore. And if you follow them all, then this process like expands beyond any control. So the hidden costs of adapting to change, handling uncertainty, comes through the management, to setting the goals, to have the clarity, and to actually decisions what not to do. Like deciding what not to do is like more important than deciding what to do. And how to do it is that you have clarity in roles. And what is often seen is, as I was referring on earlier slides, is that we automatically think that innovation is related to engineering. So and engineering has to solve it. But what engineering actually does is a bit more constrained, and it gives a value if they don't like expand out of those boundaries of what their expertise is. And at earlier stages, actually, this engineering pretty much gives a report, and maybe this experiment as well. So it's like, is the concept valid? Is the IP, is the freedom to operate, and can it be protected? How to protect it? What are the potential specifications that can be achieved? What is the architecture of the device like to be able to plan better? How to design it? And here I have actually, segment those levels differently, more closer to our innovation. And the next step is engineering to the as a proof of principle. Ourselves, we call it Frankenstein because it's a really early prototype, wires hanging loose and whatnot. And then it arrives to this demonstration prototype, and then eventually it will be a product. So, but here's like quite some missing. Like we don't have the customer, we don't know what the customer is thinking. If we started with early reports, then we don't even get the customer feedback. So the engineers only cannot solve it. So what is missing here is business development. And the best compliment I have received recently is that, oh no, you're like social scientist. And why I consider it really important is that business development is pretty much all about social science. You have to be systematic, you have to be goal-oriented, you have to know what to do, and you have to collect and analyze and process and then correct your path. So in order to succeed with the innovation process, it comes to many books and ideas of great thinkers, including the management team of Amazon. So the Amazon, as a global corporate, has done some really clever, massive innovation, and how they manage is really a really good guideline, because for the innovation, they break out specific teams to tackle certain problems, problem or project proposals they have selected from two really tough internal competition. And those teams are actually the size of a research team, in the order of 6 to 1,000 people, half a dozen to dozen, and they combine engineers and business development, like all the expertise in the same team, and the same like viability of those teams is actually evident in this bigger picture when we see that large global corporates are often buying startups. They have all the resources we can imagine. They could do innovation internally, but for some reason, they don't succeed. But instead, they go to startups, they work together, they acquire, they do all the other kind of stuff as well, which perhaps they shouldn't. So it's, and from here, the process-wise, it's really important to have this engineering and the business development, this customer expectation management and like awareness, to have them lockstep. So if engineering does the concept, business development validates the market, like who could use it. The next step, if we know it works in a lab, then we go and figure out what's the value proposition for the customer. One thing is we have the hypothesis, then we go out with the hypothesis, we talk to the customers, and then we get the feedback. And then we know again, like then we do the next iteration. Once we have a fully functional prototype, we do tech validation with customers. Once the product is out, then we go, and then we only have the paying customer. So it's like a huge journey. It's bridging the gap from technology readiness level 3 to 7, 8 is kindly called Death Valley. So that's the thing. And here's another player who says what to do and how to achieve it. And this is the owners of a company. It is well, if I was young, then it was common understanding that the business people, they have a lot of money and maybe not so many like brain power, but they are just like oversimplified, but like collecting resources and just becoming rich. But from this process, the innovation process, I don't see that model. It doesn't fit here. So what it actually does, what the owners do, is actually they are taking constant risk and responsibility. And they are, instead of gaining resources, they are investing. And they are working how to get the investments to support the innovation. So this is also to be beared in mind that what it takes. If you want to take your innovation to the wide world and change the world through the new technologies, then you have to be ready to take those risks. I have to be ready to take this responsibility. And yeah, if all those things are aligned, then I wish you best of luck and hope you will succeed in the innovation. But now let's summarize the presentation. First, what is LightCode? So we are working on 3D sensing that is based on single pixel imaging or ghost imaging. And we actually have today the IP that we can, from here, package it to a system on a chip that would end up as a camera with dimensions of dice, or it could fit into a smartphone. So that's why I'm summarizing what we do. It's ghost imaging into every pocket. So why the market matters? It's your choice to take the path of Nikola Tesla or Henry Ford. And the innovation process is we are researchers, we are using scientific methods, and it's the best news is it's transferable skill that can be applied in every aspect of building a company. And here now I'm happy to take your questions.
Yeah, thank you for sharing your valuable thoughts. Now I welcome the audience and panelists to have, if they want to discuss any kind of question. Yeah, I will be having from Dr. Igor. So, yes, sir, please.
Thank you. Very interesting talk and very inspiring. And but I'm kind of pure researcher and very far from social sciences. Could you please clarify more about why big companies do buy startups? Why they do not do themselves, please?
Yeah, they try to do themselves, and the thing is that for some reason, those pure engineer team, even if they're top talent, it's not enough in order to get this innovation out. But it's not black and white because they do get out some of the really like massive innovation, and for certain innovation you need to have like different setting than just a team of 6 or dozen. But it's also discussed in a book called Loon Shots. But you need a different competences in different stages of building a company, and the early stages you actually need to have this really strong engineer, innovator, and a market expert, like a customer feedback dialogue. So I think this is what the big corporates lack in providing to their engineers, the best engineers. And that's why they struggle also with attracting the biggest talent. But it's not black and white. Like they also have excellent ingenious teams, and they do ingenious innovation as well. So.
Thank you.
Yeah, now I would like to welcome Professor Vijay Kumar to have their thoughts.
Okay, Professor Heli Valtna, thank you very much for the wonderful presentation. So this perspective, I mean, the industrial perspective is, I think, quite interesting and also quite new to many researchers. So thank you very much. And so I have multiple questions. So if it's okay, I'll ask one by one.
Yes,
so so I have been following your LinkedIn page. So, so in that, I think LightCode is currently, I mean, its main focus is on automated driving. So, yeah. So, do you think so? You will also, I mean, develop other products, or LightCode Photonics will focus only on this direction?
At this stage, we have to strongly focus, and I would maybe like make a small adjustment. It's autonomous functions and situational awareness for to enable automated mobility, what we're doing. And the subtle difference being that if autonomous driving is mentioned, people often think about cars and cars without a human driver. This is not exactly what we are doing, or this is not where we are starting. Actually, in past roughly like 15 years, $250 billion was invested into that field. And it was the first snow that melted. But it did not solve the market need. So I think it was in a way starting from building into air in a way without supports, because it was somewhat like a huge challenge, like mammals created from bacteria kind of step. So like oversimplifying again. So, but we are now taking more evolutionary path, because those warehouses, intralogistics, those restricted areas, industrial sites, they really struggle with the logistics tasks. They need to hand those tasks to vehicles or machines, and this is where it gets started, because the environment is more simple. The environment on streets is one of the most difficult ones. Only like unstructured environment is more common.
Okay, thank you very much. So my next question is on your transition from academics to industry. So currently, I mean, how much percentage of your time is as a researcher, and how much percentage of your time is as a manager and a leader?
That's a good one, because I think it's actually the same thing.
Same?
Yeah, because I'm fully convinced. I was teaching at the university as a teacher. I'm parent. I'm transferring the skills from one domain to another, to management and the, like research, like systematic approach to planning ahead, and it's all the same thing.
Okay, thank you very much. So I have, another question on. So when you presented, you also mentioned that the academic research was fun, and then now life is more serious. So then in that case, so what drives you?
Well, I think it's still really like fun. It's still amazing. What surprised me most is that I was not aware that if you go to innovation, you do a company, then there are some awards. I thought you do a company, and if you have customers, that's your award and reward and everything. But we have been noticed, and we have this amazing startup community here in Estonia. So people talk about us behind our backs, but they are saying good things. So that's completely new concept. Need to get used to that. Well, like leaving the jokes aside, I think this ecosystem is actually really important as well in order to succeed. And it's still like, I think I was like entrepreneur undercover in academia. Thomas Planck can tell stories probably what I did in and what he did and where he sent me often. Well, it was all friendly. But yeah, it's just I think it's goal setting and planning and understanding the structures and making it happen and applying scientific methods.
Okay, yeah, thank you very much.
Thank you, Professor. So we'll wait. Some others will be. Any questions from the audiences? Okay, so, there will be no questions. Thank you, Professor Heli Valtna. It's like a roller coaster ride because you consolidated 3 to 4 years of your entrepreneurial journey within 20 or 30 minutes. So in addition, in added to Professor Anand questions, and I'll be having only 2 questions related to that. So is it okay for you? Hello, am I audible?
Yeah.
Yeah. So related to your computer vision, you said that you are implementing the 3D kind of vision to your delivery robots, right? So my question is related to the safety and reliability of the delivery robots, particularly in high density traffic in the unpredicted situations. So how you are handling these kind of things?
Yeah, well, for safety, there are like regulations and you just need to comply. But there are like existing commercially available solutions to address it, so we don't have to go, we don't have to start from there. But all in all, yeah, it's compliance to regulations eventually. But in the beginning, it's everything about like proving the worth of this technology.
And in addition to that, I'll be having one more question related to that. What kind of capabilities or else functionalities can we expect from the light photonics in the upcoming years? Advancements in case of.
I'm sorry, my connection was breaking. Could you repeat the last part?
Yeah, what kind of new capabilities or else functionalities can we expect in the light photonics in the upcoming years?
Well, it's a step-by-step process. So first we have to get the validation on the first market. If that is strong, then we can proceed. On the roadmap is to make this technology more integrated and more compact. And eventually, like if we take this really bold looks ahead, something like 10, 15, 20 years perhaps. It's really hard to put the number here. But then this 3D camera could fit or like could complement every CMOS sensor. So this is if we are in every 15 billion CMOS sensors with our technology and enable them to see in 3D in low light conditions and in parallel with visual, then we're definitely we're done. And it's obvious that there we will not get alone, but we will be heavily partnering with global sensor developers.
Okay, we'll be having one more question from our project manager, Tia Lama. So I just give the rest to Tia Lama now.
Yes. Heli, can you tell us what are the benefits of start a company in Estonia or do research in Estonia?
Well, I think, well, it's like if you take some benchmark from the past. So at the Soviet times, it was like a manifestation of a freedom. You had to be smart in order to be in a way free and gain the freedom out of the system in a way. So you were so smart that they couldn't stop you. But I think in a way, nowadays it gives a purpose, like doing a science and being an entrepreneur. And as I said, for me, it's like part of the same thing. If I compare Estonia to other countries, Estonia, we have really good startup ecosystem, but this is only for early stages. So I think for both academia and the strength of the education and the strength of the business ecosystem or startup ecosystem, it's a really good help me with the English word hüppelaud, at a really good starting point, the jumping board. So this is like it's a really friendly